We're here at the example table, and in this video we're going to be looking at equations with variable exponents. Let's look at an example. Let's suppose we want to solve 2 to the x plus 5 equals 2 to the 3x. Well, if 2 raised to some power equals 2 raised to another power, then these two powers must be the same. So this is the same as solving x plus 5 equals 3x. We subtract x from both sides, we get 5 equals 2x. So finally, x equals 5 over 2. I want to talk in a little bit more detail, though, about why we can go from this step to this step. In other words, 2 to the some power equals 2 to the some other power means that those two powers must be the same. So let's consider this graph. And let's suppose that this is y equals a to the x. And here we're assuming that a is greater than 1, which is why this curve goes like this. If it were between 0 and 1, it would go like this. If we know that two outputs of this thing, in other words, a to the, I shouldn't use x, let's say a to the c equals a to the d, in other words, both outputs of this function land at the same y value, then we can see from this graph that there is only one place these two outputs could have come from. So in other words, this point here must be both C and D. For those of you who have seen the horizontal line test, this is essentially the same idea that we're seeing here. This graph passes the horizontal line test. Any outputs that are the same must come from the same inputs. So this is why in the previous example, we could say that x plus 5 equals 3x. So let's look at another example. Let's say 2 to the x squared minus 1 equals 2 to the 5th. The exponents, these expressions are the same, so that means that the exponents must be the same. So we get x squared minus 1 equals 5. So x squared equals 6. So x is plus or minus the square root of 6. So it's worth noting that the two answers we got here came from the fact that one of these exponents was a quadratic. It's not from the fact that we went from 2 to the something equals 2 to the something to those two somethings being the same. Let's look at one more example. Let's suppose that 2 to the 7x equals 4 cubed. We want to do the same thing, except now our bases aren't the same. But with a little bit of rewriting, we can make them the same. So we could write 4 cubed as 2 squared cubed. And using our rules for exponents, we can write this as 2 to the 2 times 3 power, or simply 2 to the 6th power. Once we've done that, we have the same situation. So 2 to the 7x equals 2 to the 6th. So 7x equals 6, which means that x equals 6/7.